a three-phase power system supplying single-phase loads, the current in phase C will be the sum of the currents in phases A and B, given the load configuration described. This principle is governed by Kirchhoff's current law, often abbreviated as KCL. Kirchhoff's current law states that the total current entering a node, which is a junction where multiple circuit branches connect, must equal the total current leaving the node. In a three-phase system with a neutral point, the neutral point serves as this node. Currents from phases A and B flow into this node, while the current from phase C flows out, completing the circuit. Therefore, adhering to KCL, the current in phase C, denoted as I, must be equal to the sum of the currents in phase A, denoted as I, and phase B, denoted as IB. Mathematically, this relationship is expressed as I equals I plus IB. In the specific scenario where two air conditioning units, each drawing 10 amps, are connected as described, the calculation is straightforward. One air conditioner is connected between phase A and phase C, and the other is connected between phase B and phase C. This means that phase A carries 10 amps to supply the first air conditioner, and phase B carries 10 amps to supply the second air conditioner. Since phase C provides the return path for both air conditioners, it must carry the sum of the currents from phase A and phase B. Therefore, the total current in phase C is calculated as follows: I equals 10 amps plus 10 amps, which equals 20 amps. This result confirms that phase C will carry a current equal to double the current in either phase A or phase B. It is important to note that this analysis assumes a balanced system where the voltage and impedance in each phase are equal. In real-world applications, slight imbalances may occur due to variations in load impedance or voltage fluctuations. However, the fundamental principle of Kirchhoff's current law still applies, and the current in phase C will still be approximately equal to the sum of the currents in phases A and B. When working with three-phase power systems, it's crucial to accurately measure and monitor the currents in each phase to ensure proper load balancing and prevent overloads. Overloads can lead to equipment damage, reduced efficiency, and even safety hazards. The neutral conductor in a three-phase system is intended to carry the imbalanced current. However, if the current in the neutral conductor is excessive, it indicates an imbalance in the system. An unbalanced system can cause voltage fluctuations, equipment overheating, and reduce system efficiency. Common causes of unbalanced currents include uneven distribution of single-phase loads, faults in the wiring, and variations in equipment impedance. To mitigate these issues, it is essential to distribute single-phase loads evenly across the three phases. Regularly inspect and maintain the wiring to identify and correct any faults or loose connections. Using equipment with consistent impedance characteristics is also recommended. Proper load balancing ensures that the current is distributed evenly among the phases, minimizing the current in the neutral conductor and improving the overall efficiency and reliability of the electrical system. Additionally, consider using phase monitoring devices that can provide real-time information about the current and voltage in each phase. These devices can help identify imbalances and potential problems before they escalate into major issues. When troubleshooting current imbalances, it's recommended to use an ammeter to measure the current in each phase. This will help pinpoint the source of the imbalance. If a particular circuit is drawing excessive current, investigate the connected loads to identify any faulty equipment or overloaded circuits. If the current in the neutral conductor is high, it indicates that the load is not evenly distributed among the phases. Consider redistributing the loads to balance the current more evenly. In some cases, it may be necessary to upgrade the wiring or equipment to accommodate the load demand. Working with electrical systems can be dangerous, so always follow proper safety procedures and wear appropriate personal protective equipment. If you're not comfortable working with electricity, it's best to consult a qualified electrician. Keep in mind that in more complex scenarios, factors such as power factor and harmonic distortion could also influence the current distribution in the system. Power factor is a measure of how effectively electrical power is being used. A low power factor can result in increased current draw, leading to higher energy costs and potential equipment overheating. Harmonic distortion is the presence of unwanted frequencies in the electrical system. Harmonic distortion can also cause increased current draw, as well as equipment malfunction and interference with other electronic devices. To mitigate these effects, power factor correction equipment and harmonic filters can be installed. Power factor correction equipment improves the power factor by reducing the reactive power component of the current. Harmonic filters reduce the amount of harmonic distortion in the system by blocking or absorbing the unwanted frequencies. In addition to these factors, the type of grounding system used can also affect the current distribution. There are several types of grounding systems, including grounded systems and ungrounded systems. Grounded systems provide a path for fault current to flow back to the source, which helps to protect equipment and personnel from electrical shock. Ungrounded systems do not provide a direct path for fault current to flow back to the source, which can make it more difficult to detect and clear faults. The choice of grounding system depends on the specific application and the level of safety required. Grounding conductors play a crucial role in electrical safety. They provide a low impedance path for fault current to flow back to the source, which helps to trip circuit breakers and protect equipment and personnel from electrical shock. Grounding conductors should be properly sized and installed to ensure that they can safely carry the fault current. Bonding conductors are used to connect different metal parts of an electrical system together, which helps to equalize the voltage potential and reduce the risk of electrical shock. Bonding conductors should also be properly sized and installed to ensure that they can effectively equalize the voltage potential. Surge protection devices, also known as transient voltage surge suppressors, are used to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, switching operations, and other disturbances. Surge protection devices divert the surge current away from the protected equipment, which helps to prevent damage. Overcurrent protection devices, such as circuit breakers and fuses, are used to protect electrical circuits from overcurrents. Overcurrents can be caused by short circuits, overloads, and other faults. Overcurrent protection devices interrupt the flow of current when an overcurrent is detected, which helps to prevent damage to the wiring and equipment. When designing and installing electrical systems, it's important to comply with all applicable codes and standards. These codes and standards provide guidance on the safe and proper installation of electrical systems. The National Electrical Code, often abbreviated as NEC, is a widely adopted set of standards for electrical installations in the United States. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. State and local codes may also apply. It's always recommended to consult with a qualified electrical engineer or electrician to ensure that the electrical system is designed and installed in accordance with all applicable codes and standards. Electrical systems should be regularly inspected and maintained to ensure that they are operating safely and efficiently. Regular inspections can help identify potential problems before they escalate into major issues. Maintenance activities such as tightening connections, cleaning equipment, and testing protective devices can help to extend the life of the electrical system and prevent failures. When working with electrical systems, always follow lockout/tagout procedures to ensure that the power is turned off and locked out before any work is performed. Lockout/tagout procedures are designed to protect workers from electrical shock and other hazards. Always use appropriate personal protective equipment, such as safety glasses, gloves, and insulated tools. Electrical safety is paramount, and it's never worth taking risks when working with electricity. If you're not sure how to perform a task safely, consult with a qualified electrician. The size of the conductors must be appropriate for the load that they will carry. The NEC provides tables that specify the allowable ampacities of different types of conductors. These tables take into account factors such as the conductor material, insulation type, and ambient temperature. It's essential to select conductors that are large enough to carry the load current without overheating. Overheated conductors can cause insulation damage, equipment failure, and even fires. The voltage drop in a circuit should also be considered when selecting conductors. Voltage drop is the decrease in voltage that occurs as current flows through a conductor. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting the voltage drop in branch circuits to 3% and in feeders to 5%. To reduce voltage drop, use larger conductors or shorten the length of the circuit. When installing conductors, it's important to follow proper wiring methods. The NEC specifies different wiring methods for different applications. These wiring methods cover topics such as conduit installation, cable support, and conductor termination. Proper wiring methods help to ensure that the electrical system is safe and reliable. Conduit is a type of tubing that is used to protect conductors from physical damage and environmental factors. There are different types of conduit, including rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and flexible metal conduit. The type of conduit used depends on the specific application and the level of protection required. Cable trays are used to support and route cables in industrial and commercial applications. Cable trays are available in different materials such as steel, aluminum, and fiberglass. The type of cable tray used depends on the weight and type of cables being supported. When terminating conductors, it's essential to use proper connectors. There are different types of connectors, including wire nuts, crimp connectors, and terminal blocks. The type of connector used depends on the conductor size and type. Improperly terminated conductors can cause loose connections, overheating, and equipment failure. Ground fault circuit interrupters, commonly referred to as GFCIs, are used to protect people from electrical shock. GFCIs detect ground faults, which are unintended electrical paths to ground. When a ground fault is detected, the GFCI trips the circuit, interrupting the flow of current and preventing electrical shock. GFCIs are required in certain locations such as bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters, frequently called offsides, are used to protect electrical circuits from arc faults. Arc faults are dangerous electrical discharges that can cause fires. Offsides detect arc faults and trip the circuit, interrupting the flow of current and preventing fires. Offsides are required in certain locations, such as bedrooms. Electrical panels are used to distribute electrical power to different circuits. Electrical panels contain circuit breakers or fuses that protect the circuits from overcurrents. The electrical panels should be properly labeled to identify the circuits that they serve. Electrical panels should be regularly inspected and maintained to ensure that they are operating safely and efficiently. Transformers are used to step up or step down voltage levels. Transformers are essential components of electrical power systems. Transformers should be properly sized for the load that they will serve. Transformers should be regularly inspected and maintained to ensure that they are operating safely and efficiently. Motors are used to convert electrical energy into mechanical energy. Motors are used in a wide range of applications such as pumps, fans, and compressors. Motors should be properly sized for the load that they will serve. Motors should be regularly inspected and maintained to ensure that they are operating safely and efficiently. Variable frequency drives, abbreviated as VFD, are used to control the speed of motors. VFD can save energy by reducing the speed of motors when they are not needed to operate at full speed. VFD can also improve the performance of motors by providing smooth starting and stopping. Lighting is an essential component of any electrical system. There are different types of lighting, including incandescent, fluorescent, and LED lighting. LED lighting is the most energy-efficient type of lighting. Lighting should be designed to provide adequate illumination for the task being performed. Emergency lighting is used to provide illumination during power outages. Emergency lighting is required in certain locations, such as exit stairwells and corridors. Fire alarm systems are used to detect fires and alert occupants. Fire alarm systems should be regularly inspected and maintained to ensure that they are operating properly. Security systems are used to protect buildings and assets from theft and vandalism. Security systems can include cameras, alarms, and access control systems. Data and communication systems are used to transmit data and voice signals. Data and communication systems can include cabling, network equipment, and telephone systems. Renewable energy systems such as solar and wind power systems are used to generate electricity from renewable resources. Renewable energy systems can help to reduce reliance on fossil fuels and lower energy costs. Electrical safety training is essential for anyone who works with electrical systems. Electrical safety training should cover topics such as electrical hazards, lockout/tagout procedures, and the use of personal protective equipment. By following safe work practices and adhering to electrical codes and standards, the risk of electrical accidents can be significantly reduced. The ongoing development of electrical technology continues to bring improvements in efficiency, safety, and reliability. Staying informed about the latest advancements is crucial for professionals in the field to ensure they are utilizing the best practices and equipment available.